My name is Noor Achira and I'm going to present the part of introduction. So for the introduction, Novas Construction Sdn Bhd, established in 2016, is a leading Malaysian company specializing in geotechnical and foundation engineering. It offers services like soil testing, foundation design, and slope stability assessment. With a focus on safety, efficiency, and sustainability, Nafas has completed numerous major projects across Malaysia and remained a trusted leader in the industry. So next is mission and vision. For our mission, Nafas Construction Sdn Bhd aims to provide innovative, sustainable, and high-quality foundation engineering solutions. With a focus on excellence, advanced technology and skill expertise, the company ensured the safety, stability, and long-term success of its project, contributing to the growth of infrastructure in Johor and beyond. So for the vision, our vision is to be the most foremost provider of innovative and sustainable foundation engineering solution, recognized for our dedication to excellence, safety, and customer satisfaction. We aim to foster the growth and development of infrastructure in Johor and beyond by consistently advancing our technologies and expertise, ensuring the lasting success of every project we undertake. So for the problem statement, the main challenge of this project is choosing the right foundation system for the proposed structure in Kota Puteri. With varying soil conditions and fluctuating groundwater levels, a detailed analysis is required to select between shallow or deep foundation. Proper load distribution and foundation sizing are crucial to avoid issues like settlement or instability. Finding a safe and cost-effective foundation design is key to the project's success. That's all from me. Thank you.
My name is Nur Anis Akila binti Abdul Wahid. My metric number DF220018. So I will continue to talk about soil investigation and foundation assessment. For the proposed single-story house in Kuala Lumpur, Master Testing Services Sdn Bhd conducted soil testing according to BS 1377-1990. Both disturbed and undisturbed samples were tested to determine moisture content, particle size distribution, shear strength, and bearing capacity. Using this result, Nafas Sdn Bhd evaluated the soil behavior and foundation stability. They identified unstable zones and potential settlement risks. Based on the findings, a suitable foundation system was recommended to ensure long-term structural stability. For the project location, this section presents the soil investigation conducted for a proposed single-story residential building located in Kota Puteri, Kuala Lumpur. The main objective of the investigation was to gather geotechnical information about the surface conditions. This data is crucial for designing and selecting a suitable foundation system that ensures the long-term stability of the structure. To carry out the investigation, a borehole was drilled using the YWE D90R rotary boring machine. Through this process, soil samples were collected for laboratory analysis to assess the soil properties. The structural layout of the building, including column loading, is illustrated in Figure 3.1, which supports the foundation design process. Next, I want to talk about borehole overview. A borehole records underground conditions found during borehole drilling at construction sites. It includes details like soil and rock type, texture, color, moisture, and groundwater presence. This data is crucial for assessing site suitability and designing safe foundations. The log also notes borehole depth, diameter, and drilling methods. Lab tests on collected sample reveal important soil properties such as strength, density, and moisture content. In situ testing may also be done for quick ground data. Overall, borehole help engineers choose the right foundation and construction method for the site. Next, I want to talk about soil analysis, soil profile analysis. The borehole logs, borehole 1, borehole 2, and borehole 3 give us a clear picture of the surface condition at the site. Borehole 1 shows a clay in the upper layer and silt below with N value increasing from 13 to 100, indicating stronger soil at deeper levels. Borehole 2 mainly consists of silt and clay. The N value range from 7 to 19 with a hard layer at the bottom showing an N value of 50 and refusal, which suggests very dense material. For borehole tree, start with silt followed by a layer of gravel and end with very stiff silt, and value go from to 7 at the top to 50 over 170 at the bottom, again showing increasing strength with depth. Overall, all borehole confirm that deeper layers are stronger, which support the need for a foundation that reaches those stable layers.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nasir Atawar bin Marazwan, and I will present about design foundation. Shallow foundation. A shallow foundation is defined as one constructed at a depth less than twice its width. Second, it is commonly used in low-risk construction due to its simplicity and cost-effectiveness. Shallow foundations include types such as pad footing, strap footing, and rough foundation, each selected based on site condition and structural load requirement. Okay, design requirements. The design must ensure adequate bearing capacity to resist shear failure in the underlying soil. Second, settlement must be controlled to prevent excessive movement on structural damage. A square pad footing is often recommended for uniform load distribution. The groundwater table is located below the foundation level, reducing the risk of soil weakening due to water. Okay, then pad footing function. Pad footing are effective at transferring concentrate loads from columns directly to the ground. They help reduce the risk of shear failure by distributing vertical loads over a wider area. Proper sizing of pad footing minimises the potential for settlement. The dimensions of the footings are determined based on the column load, the compressibility of the soil, and the allowable bearing capacity.
Okay, my name is Fakir and my slide is about the design foundation. So this is the table that we use to design the foundation, which is the coefficient is 20, depth of foundation is 3, and there is no pressure angle. And the effectiveness of the foundation is 57, unit of soil 19, and the bearing capacity factor NC 5.14, NQ is 1, and N is 0. Okay, this is the calculation to us for find the right size for the foundation. So this is the soil properties, and we have the point load from the column. We use the Mayoff equation, and then we find the shape factor, depth factor, inclination factor. Since B is not given, so we assume that the inclination is 1. So and then we put it inside the formula with the to find the QU value, and we have that the QU is 270.26 B plus 57. After that, we use the formula Q allowable, which is Q divided by B square. From this formula, we get that B is 1.5 meter, and the finalized size for the foundation is 1.5 times 1.5 times 3. That is the size for our foundation. After we get the size set, so we drew, and we get that our saturated soil is below the foundation. So we use the case 2. So the Mayer-Hoff equation, we get that the ny is 0, and then we calculate the shear factor, the depth factor, and the inclination factor, and we get that the new QU is 234.27 kilonewton per meter square, and we check the Q allowable is 78.09. For and then we have to calculate the Q value, the Q itself value, which is the Q number times B square. We get that 171 175 0.70 kilonewton. That is the load. Okay, after we design the foundation, don't forget to calculate the settlement for the foundation. Uh, we need to check the elastic equipment. First, we use the formula SE equal A1 A2 Q naught times B divided ES. We use this formula because we have clay in our soil. So the Q we get is 72.22 kilonewton square, and this is the foundation that we drew. And then to get the AI value, we need to get the hash per B and L per B first to uh, to ask for find the A1 value, which is the A1 value is 0.78, and then we calculate the and then we get the A2 value, which is the 0.94 from the graph settlement classic. And then after that we get all the we get all the information. We just put inside the formula, and then we get the finalized answer is 1.23 millimeter for the settlement.
Detailing of foundation. Okay, as you can see here, we have two type of foundation. The left one we use square foundation, and it got one piling only, and the right one we use rectangular foundation and got two piling, and the column is only one. And we in the detailing we can find the length of the foundation and the size of the foundation. That's all for the foundation detailing.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Syakir Wira Iskandar. My matrix number DF22053. Okay, now we go to the site investigation. The site investigation was conducted in Kota Puteri by Master Testing Service using BS 1377-1990. The purpose was to determine soil characteristic for selecting a suitable foundation system for a single-story home. 3 boreholes were drilled and both field and lab tests were carried out. The results show mainly stiff to very stiff sandy clays and silt, with N value ranging from 7 to over 50 and a maximum N value of 100 at 12.2 meter depth. The upper 2.5 meter had very stiff clay, which is good for shallow foundation. Additionally, no groundwater was found at the foundation level, reducing the risk of soil weakening or buoyancy issue. Okay, next, soil improvement. Improving soil condition is key to ensuring a stable foundation, starting with compaction. Using method like rolling or vibrating to increase soil density. The Proctor test helps determine the best moisture content for this. Additives such as lime or cement can further enhance the soil strength, and geotextiles add extra support. Drainage is also critical. Surface drain prevent erosion, while subsurface system like French drains helps lower the groundwater level. In poor soil condition, replace weak soil with engineered fill or use grouting to strengthen and fill voids. Before choosing the right method, a full soil investigation is necessary, testing properties like shear strength and particle size, while also calculating bearing capacity and predicting settlement. For reactive or expensive soil, we can use a buffer layer or moisture control. Ongoing drainage and pollution checks during construction helps ensure long-term safety and reliability of the foundation. Now we go to the discussion. The foundation design at Kota Puteri was based on detailed soil investigation, which involved drilling 3 boreholes and conducting lab tests. Results show the site had stiff to very stiff sandy clay and silt, with N value from 7 to over 50 indicating stronger soil with depth. Importantly, no groundwater was detected at the footing level, reducing risk of instability. Based on this data, shallow foundation with individual pad footings were chosen for the single-story building. This was suitable for the column loads ranging from 93 to 325 kN. The design applied the Mayhoff bearing capacity formula using a cohesion value of 20 and effective stress of 57, with a safety factor to prevent shear failure and limit settlement. Pad footing proved their practicality, and they effectively spread loads, show low differential settlement due to soil uniformity, and minimize risk. With reinforced footing design, the system offers a strong, long-lasting, and economical foundation solution. In conclusion, the soil analysis at Kota Putri played a vital role in understanding the subsurface condition, which guided the decision to use shallow foundation with stiff sandy clay, high N values near the surface, and no groundwater. The site was ideal for individual bed footings. These footings were chosen not only for their structural adequacy but also for their cost efficiency and ease of construction. The foundation design used Meyerhoff bearing capacity theory and elastic settlement analysis to ensure the soil could handle the expected load safely. Ultimately, this foundation system meets both structural and geotechnical requirements, ensuring long-term safety, durability, and performance for the residential building.